Okay, so here's number 6, the mean value theorem worksheet. F of x equals the square root of 2 minus x on this closed interval -7 to 2. So let's see what's this going to look like. First of all, because I got to check to see if it's continuous on this interval. We got square roots. We got some issues with the square root, so we know it's got to be greater than 0. Greater than or equal to 0 for it to be defined. We can also look at the graph. Now, this is the same thing as the square root of -x plus 2, which is the same thing as the square root of negative and then x minus 2. So if we just look at the sketch, we can just see that here's our 2. And this looks like this is, John Travolta, but it looks like it's flipped because we got a negative in front of the x, so it's flipped about the y-axis. In this case, the axis is 2, but it's shifted over 2, so it's going to look something like this. Okay, so it's going to look like that. I should maybe highlight that in green. And so this is what the function graphs. That's why you want to know your parent functions and how to graph them. Y equals the square root of 2 minus x. So it looks like this. We also know that 2 minus x has got to be greater than or equal to 0. We could also say that 2 minus x must be greater than or equal to 0 for it to be defined. So we could say 2 has got to be greater than or equal to x, or x has got to be less than or equal to 2. So again, on this interval, we're okay on the closed interval. It's all right because it's less than or equal to 2. If there was 3 there, we'd be in trouble. All right, it would be defined. So we can say that f of x is continuous, and you can see it's a smooth curve, so f of x is continuous on this closed interval, -7 to 2. And it's nice to see it graphically. I think it makes a little more sense. Now, is it differentiable? Well, we might have a problem right at 2 here, but we just have to worry. It's the open interval, but we can take the derivative anyway. So let's say f prime of x equals, and this is going to be 1 over 2 times the square root of 2 minus x times the derivative of the inside, which would be negative. So that's what we have for our derivative. And the only place where there's a problem is when x is equal to 2, because then we would have a 0 in the denominator. But we're not interested in 2 because we want to make sure it's continuous on the, differentiable on the open interval. And 2 is not in the open interval. So we'd say that f of x is differentiable on the open interval, -7 to 2. It's not differentiable on the closed interval because it's not differentiable at 2, because 2 minus 2 is 0. We got 0 in the bottom, so that doesn't exist. But we don't have to worry about that because, actually we have a, probably a vertical tangent right there. It's approaching infinity, so we have a vertical tangent there. You can see how that slope gets. It's probably approaching negative infinity because the slope is negative, more negative, so we're approaching negative infinity there. So but either it doesn't matter. We just have an infinite tangent, so we're going to have a vertical tangent line, so we're not going to have anything going on. We won't have a derivative at 2, but we're only worried about the mean value theorem. Is only concerned about the open interval, and 2 is not in the open interval, so that's the only place we have problems. So this is differentiable. So therefore, the mean value theorem applies. So we can say therefore, by the mean value theorem, we know there exists. We should maybe say therefore by the mean value theorem, there exists a C belonging to the open interval, -7, 2, such that f prime of C equals f of b minus f of a all over b minus a, or the instantaneous rate of change equals the average rate of change, or the slope of the tangent line equals the slope of the secant line. All the same idea. So what's f prime of c? So f prime of, well, c, we'll just write that f prime of c, so we have negative 1 all over 2 times the square root of 2 minus c. This looks interesting. And that's going to be equal to, so what's f of b? So it'd be, and this is going to be my a and b here. So what's f of 2? That's going to equal, well, that's going to be 0, isn't it? Because 2 minus 2 is 0. And what's f of negative 7 going to be? And that's going to be, yep. So that's going to be 2 minus 7. So that's going to be the square root of it. 2 minus, and x is negative 7. And that's going to be 2 plus 7 is 9. That's going to be 3. Okay. So there's your f of b minus f of a, and then your b is going to be 2 minus 7. All right. And we can kind of simplify that. That's going to be negative, oh, sorry, 2 minus negative 7. There I go. Watch that double negative. So that's going to be 2 minus negative 7, excuse me, because b is negative 7. I'm sorry, a is negative 7, excuse me. So that's going to be 2 minus negative 7. So that's going to be negative 3 over, and 2 plus 7 is 9, so it's going to be negative 1/3. So negative 1 over 2 times the square root of 2 minus c equals negative 1/3. There we go. Okay, yeah, watch those negatives a couple times. Almost got me. All right. And a negative time, we've got a negative on both sides, so we divide both sides by negative 1, so we get rid of that sign. That makes it easy. Then we can just kind of multiply both sides by 3 times 2 times the square root of 2 minus c. So we have 3 over here on the left, and that equals 2 times square root of 2 minus c. Then we can divide by 2, so you have 3 over 2 equals square root of 2 minus c. And then we can square both sides. So if I square this, I get 9 over 4 equals 2 minus c. And then if I add c to both sides and I subtract 9 over 4, I get c equals 2 minus 9 over 4. And that's the same thing as 8 over 4 minus 9 over 4. So c would equal negative 1/4. And is negative 1/4, so let's take a look. So negative 1/4, does that belong to this interval, the open interval, negative 7, 2? It sure does. So therefore, c equals negative 1/4. All right? So that's how it works with a lot of detail, a lot of nuance. And that's kind of a tricky one. So you have to know your algebra, you have to know your arithmetic. I hope that's perfectly clear.